Hey everyone, and welcome to this video on the engineering design process. I wanted to get things started off by asking you a question, which is, what is the main difference between scientists and engineers? You might think that those two professions are pretty similar, but a good way that I've heard about differentiating the two is to think of it this way. Scientists look at the world and they see the way that it is, and they ask themselves, why is the world the way that it is? Whereas an engineer, on the other hand, they look at the world and they see what could be, and they ask, why not? The fundamental difference between these two professions is that scientists tend to develop theory, whereas engineers tend to apply theory. Really, the dividing line between these two fields, then, is that engineers design. They take all of the science, math, and other knowledge that they are aware of, and they apply that to solve problems. In today's video, we're going to learn more about how engineers apply their knowledge through what's called the design process to tackle all sorts of different problems.
Before we begin talking about the design process, let's define the word design. If we look in our favorite book, the dictionary, we can figure out that the definition of the word design is the following. It means to create, fashion, execute, or construct according to plan, or to conceive and plan out. Ultimately, it means to have as a purpose. As we move forward, a design is something that engineers will create that we want to execute to plan in order to fulfill some desired need. Because designs can be both simple and complex, engineers have created a structure known as the engineering design process to help them organize their thoughts and ideas and bring their designs into reality. You can see a couple examples of the design process shown here.
As you can see, the engineering design process can be defined and diagrammed in all sorts of different ways. But one thing you should realize is that the design process does not flow in a linear progression like a river or a stream. Instead, the engineering design process is iterative and constantly circles back in on itself. It doesn't necessarily have to start in any particular place, but what you'll see is that it constantly repeats and flows. And while there are many different definitions and step-by-step patterns for the design process that one could follow or see out there, let me show you kind of my favorite model that I've distilled things down to. To me, I like to model the engineering design process into 6 distinct steps. I'm going to put a circle over here so we can organize all of these different steps in order so that you can see how the general flow of the engineering design process works. Now, the first and probably most important step of the design process is step number 1, which is research and define your problem. As an engineer and a person in the world, you cannot solve a problem unless you really, truly understand what that problem is. So by doing research and interviews, you'll go out and you'll really try to understand what the issue is that you're trying to tackle. After you've done that, step number 2 of the engineering design process is to identify the constraints and the resources you have available to you to address this problem. And after you've kind of figured out those bounds in which you are working, step number 3 is the fun step. It's the ideation and brainstorming phase in which you imagine as many possible solutions as you can. In this process here, you really want to be creative and think outside the box. Here, you want to develop as many wild and crazy ideas as you can, because although they may seem pretty ridiculous in the beginning, it may turn out that one of those ideas turns out to be fruitful and leads you to a really practical and successful idea later down the road. After you've done that, step number 4 is to start to plan and really think about what some of these possible solutions might look like. And after you've considered some of these options, step number 5 is you pick some of your favorite or the ultimate best one so far, and you create a model and a prototype. And in this phase, you really test everything that you've come up with thus far. And I can tell you, in the history of ENES 100 and in the history of engineering more generally, this is where you get to see where things work or they don't work. And I can tell you, there have been a lot more things that don't work than that have worked. But this is really an important part of the engineering design process and of life more generally. Learning from failures. Because it's by doing this that you really get to see all of the work you've done and to see whether or not it has come together in the end to solve your problem, or if there's more work yet to be done. Which is why the final step in the engineering design process, step number 6, is to reflect and redesign. you'll take all of the experiences you've had throughout this process and you'll figure out whether the solution you have is done or if it still needs more work. The engineering design process is never ending. It constantly flows as you iterate through the cycle and hopefully over time get better and better and better and ultimately solve and address the issue that you set out to in the first place.
Hi, I'm Josh, and I'm a member of Engineers Without Borders at University of Maryland. What Engineers Without Borders does is it pairs talented young students with communities across the globe to provide engineering solutions to the problems that those communities have. Whether it's access to clean, safe drinking water, reliable electricity, or sound structures like buildings and bridges, Engineers Without Borders takes these young engineers and gives them hands-on experience in solving some of these challenging real-world problems. In this example, Engineers Without Borders will be solving a water quality and access problem for a community in the developing world. The first step of our design process is the research and define phase. This normally involves an assessment trip where we interview stakeholders. Not just the leadership of the community, we want to interview all members of the affected community so that everybody's voice is heard. We might run tests, like water quality testing, and we also are trying to get a baseline of what the current community's access to clean, reliable water is, both in the quality of that water and in the amounts. After establishing a baseline, the second phase in the design process is identifying needs and constraints. In this phase, we want to figure out what's going to limit our design. This might be things like time, like the amount of time that we have on an implementation trip to build a design. Money, like the amount of money that we have on to buy materials. Location, which might include specific constraints about the location that we're working on, such as the soil conditions. And resources, both physical and academic. Physical might be what materials are available in the community to build with, and academic might include what skills do our students have when it comes to designing these complex engineering solutions. The third phase in the design process is imagine possible solutions. In this phase, we go through brainstorming activities like the one pictured here. There are a few rules in a brainstorming session. The first is to defer judgment. You never know if an idea is going to be a good idea until later on down the line when you're actually evaluating them. Let people come up with as many crazy and wacky ideas, because oftentimes these are some of the best. Be visual. When we're brainstorming, oftentimes we write it down on Post-its like we're doing in this session, but nothing gets an idea across faster than a drawing. It doesn't matter how good of an artist you are, drawing helps you communicate details much more effectively than any written or spoken word can. Try to build off the ideas of others. Be positive when you do this, and if you ever come up with an idea that builds off of someone else's, always say, I love your idea, and go for quantity. The goal of a good brainstorming session isn't to generate good ideas. It's to generate many ideas. In the first part of our brainstorming activity, our designers were undergoing divergent thinking. During divergent thinking, the scope of our project isn't necessarily getting wider, but the number of different solutions and designs that our designers are coming up with is. Once you have a nice, healthy amount of potential solutions and designs, then we should move into the next phase of our design process, which is planning and selecting the best possible solution. In this phase, our designers are now undergoing convergent thinking. This is where we take all of our different designs and we start evaluating them based on their merits so that we can select the best possible solution to our problem. The next phase in the design process is creating and testing prototypes. Just because you've selected your solution doesn't mean you know everything about it. We build prototypes so we can figure out minute details and nuances about the solution that we've selected. Here at the University of Maryland, we have tons of really cool labs where you can build prototypes of the design you've selected, like the lab I'm in now. In ENES 100, you have access to 3D printers, which is a form of additive manufacturing that can quickly convert CAD models to tangible artifacts. We also have laser cutters, which are really great for cutting and engraving flat 2D parts. We even have a wood shop, which is great for building both functional and decorative wooden products. The wood shop is stocked with really great tools like a bandsaw, table saw, miter saw, sander, planer, scroll saw, and drill presses. All these resources combine together to help you bring your prototypes to life. Keep in mind, a prototype doesn't have to be something that does everything. It can be an artifact that looks like, feels like, sounds like, or acts like the finished product. You're just trying to test out minor details of what you think your final product will be. The final phase of the process is reflect and redesign. Designs are never finished. There's always something you can look back on and think of ways to improve. The engineering process as a whole is an iterative process. It's constantly repeating and cycling so that the solution that you finally deliver is the best possible solution to the problem you set out to solve. To think like a designer requires that you come up with all sorts of wacky ideas, that you take the time out of your day to prototype and come up with tests, and always be willing to fail early and often. A good designer should always keep people at the center of their design, and you should always be listening to people directly so that you can arrive at the optimal solution that fits to the problem at hand. A designer often goes through a series of highs and lows during the design process, but ultimately, by following the process, you can achieve the goal of designing the best possible solution to the problem at hand.